Section 1.4, Complex Numbers. The imaginary number is defined to be I, which is the square root of -1. I squared is -1. If we're evaluating square roots with negatives, the first thing we're going to do is pull out the negative. So we can rewrite this as the square root of 64 times the square root of -1. That is 8i. For the square root of -8, again, we'll pull the negative out and rewrite that as 2 square root of 2i. Complex numbers are any number that can be written in the form a plus bi, where a and b are real numbers. For example, a is a complex number. B is also a complex number. Pi is a real number and the square root of 2 is a real number. And also -12i. This is a complex number. Here, a is simply 0 and b is -12. If we want to rewrite this number in standard form, the first thing we'll do is pull I out of the square root. So -6 plus the square root of 125 times square root of -1. Simplify the square root. This is the same thing as 25 times 5 times the square root of -1. So we get -6 plus 5 square root of 5i. To add, subtract, or multiply complex numbers, we're essentially going to combine like terms. So we're going to treat this just like we would an algebraic expression. To remove those parentheses, we're going to distribute. So we have 3 plus 2i, distribute the negative sign, and now combine like terms. 3 minus 5 is -2, 2i plus 4i is 6i. Notice we're writing it in standard form where the I is last. 2 minus 6i quantity squared, we can think of that as 2 minus 6i times 2 minus 6i. Then we'll distribute 4 minus 12i minus 12i plus 36i squared. This is 4 minus 24i. And remember that I squared is -1. So we have 36 times -1, which is -36. 4 minus 36 is -32. Then we have minus 24i. Again, making sure that we put the I part last to be in standard form. Finally, in C, we're going to distribute. 5 times 5 is 25. Then we get minus 5i plus 5i minus I squared. That's 25 plus 1. Remember, I squared is -1. So we end up with 26. If z is a complex number denoted a plus bi, then the conjugate z bar is a minus bi. We're simply going to change the sign of the imaginary part. So if z is 2 minus 3i, then z bar is 2 plus 3i. for example B, z times w bar. First thing we're going to do is find zw, z times w. So we have 2 minus 3i times 4i. That is 8i minus 12i squared. Remember, I squared is -1, so this becomes 12 plus 8i. And then the conjugate, zw bar, is 12 minus 8i. Dividing complex numbers. To divide two complex numbers, we must multiply by the conjugate of the denominator, then write the result in standard form. In this first example, 1 minus I is in the denominator. We're going to multiply by the conjugate 1 plus I, and we're going to do that in the top and the bottom. If it helps, you can put parentheses around numerator and denominator. And now it's basically two multiplication problems. In the top, we get 2 plus 2i plus 3i plus 3i squared. In the denominator, we get 1 plus I minus I minus I squared. So in the numerator, we get 2 plus 5i minus 3. Remember, I squared by definition is -1. In the denominator, we get 1, the i's cancel, plus 1. So our result is -1 plus 5i over 2. Now it's not quite in standard form, we just want to separate the fraction. -1/2 plus 5/2 I. And now we're in standard form. In the next example, multiply by the conjugate of the denominator. 5 plus 12i over 5 plus 12i. So in the top, we'll distribute. 13 times 5 is 65. 13 times 12i. In the denominator, we get 25 plus 60i minus 60i minus 144i squared. Just copy down the top, and we can simplify the denominator. Notice the 60i's cancel, and -144i squared becomes plus 144. Remember, I squared is -1. Now we have 65 plus 156i divided by 169. Break apart the fraction. 65 over 169 plus 156 over 169i. And now we just want to make sure we reduce if possible. This becomes 5/13 plus 12/13 I. Make sure your answer is in standard form. Next, we'll look at powers of I. Complete the table for each power of I. So notice the first two are given. I is I squared is -1, I cubed is -I. And then negative I times I again will become 1. And if we multiply by I again, we get I to the 5th, which is simply I. If we multiply by I again, we get I to the 6th, which is the same thing as I squared, negative 1. And you can see a pattern forming. It's going to repeat every 4 powers of I. We can use this fact that there's a repeating pattern to simplify higher powers of I. Since it's repeating every 4 powers, what we can do is divide these higher powers by 4. So I'm going to see how many times 4 will go into 107. 4 goes into 10 twice. Multiply, we get an 8. Bring down the 7. 4 goes into 27 6 times. Multiply, we get a 24. Subtract, and we get a 3. So we have a remainder of 3. Remember, that's our remainder. What that means is I to the 107 is the same thing as I to the 3rd power, which if we look up here, that is negative I. We'll repeat that process here. 4 goes into 50. 1 time. Bring down the 10. Then 2. We get a remainder of 2. So I to the 50th is the same thing as I squared, which we know is negative 1. I to the negative 27. The first thing we want to do is remove the negative sign. So we're going to take that I to the denominator, and that will remove the negative sign. And so now let's take care of the 27 like we have been doing. 4 goes into 27 6 times. Multiply, we get 24 with a remainder of 3. That means this is 1 over I cubed. I cubed is negative I. And typically we don't want I in the denominator. So to undo this, we're going to multiply by the reciprocal. And that's going to give us I over negative I squared, which is I over negative negative 1, which is simply I. Next, we'll solve quadratic equations over the complex numbers. The easiest way to solve this quadratic is with the square root method. Since the square is already by itself, we'll take the square root of both sides, leaving us with x equals plus or minus 6i. In the next example, notice factoring is not going to work here. So in this case, since factoring doesn't work, we'll use the quadratic formula. X equals negative negative 2 plus or minus the square root of negative 2 squared minus 4 times 1 times 5 all over 2 times 1. That's 2 plus or minus the square root of 4 minus 20 all over 2. That's 2 plus or minus the square root of negative 16 over 2. 2 plus or minus 4i over 2. Or if we simplify more, that is 1 plus or minus 2i.